All right, let's start chapter 9. We're going to start right here at 9.1, the Pythagorean Theorem. In chapter 9, we're going to look at a lot about triangles, particularly right triangles, and no better way to start than using this theorem. Well, what is the Pythagorean Theorem? It says right here in Theorem 9.1, in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. And so hopefully you remember, hey, in algebra, you use Pythagorean theorem. It's only used in right triangles. Okay, so that's one of the main things right here that you could highlight or add to your notes. Only used in right triangles. Okay. Another thing to know is that the longest side is always the hypotenuse in a right triangle, and it is opposite of the right angle. Okay, so remember, in a right triangle, the longest side is always opposite of the 90 degrees, and it is always going to be the longest side. So when you take a look at the diagram right here, we have, and our equation is a squared plus b squared is equal to c squared. You're probably normally used to seeing the equation written out like that. However, we also have it as c squared is equal to a squared plus b squared. Uh, I like using a squared plus b squared is equal to c squared. However, there are occasions that you're going to look at later in this section where setting it up is actually in the way you see it right here, with your c squared is equal to a squared plus b squared, is actually going to be much more beneficial. But we'll get to that in a bit. So now, as we move down to this next core concepts, we're taking a look at common Pythagorean triples and some of their multiples. Definitely say that the Pythagorean triples that I have highlighted right there, make sure you memorize them. They're very helpful when it comes to the SATs and PSATs. Um, it's just stuff that hopefully you memorize, and the more you go over it, and as we take a look at it, you'll just remember. Because in geometry, algebra 2, all of your math classes here on out, where they talk about triangles, uh, you will be these numbers will pop up quite often, and especially in the SATs, they're not expecting you to do every single calculation. They want you to, hey, do you know some of the shortcuts here? Do you know some of these theorems? So if we take a look at the first group of numbers, 3, 4, 5, what they're saying right here is this, that in a right triangle, the longest side is going to be 5, and then the other two legs will happen to be 3 and 4. So by knowing that, then if I were to take those set of numbers, 3, 4, and 5, and let's say I multiply it by 2, then I'll get 6, 8, and 10. Right? If I take 3 multiplied by 2, 4 multiplied by 2, 5 multiplied by 2, we get 6, 8, and 10. And if I take 3, 4, 5 and multiply it by 3, I get 9, 12, 15. So what it's saying is that if I start with the most basic Pythagorean triple, which is 3, 4, 5, and you multiply it by each number by whatever, 3, 4, 10, that's where they put the 3x, 4x, and 5x. And so, knowing 9, 12, 15, maybe you won't know that one as well. But if you start with 3, 4, 5, you can figure out that, hey, maybe 3, 12, 15 happens to be a Pythagorean triple, because I can multiply 3, 5, and 3, 4, and 5 by 3. And so you'll see that same pattern repeated in the little diagram right here. We start with the basic 5, 12, 13, another very commonly used Pythagorean triple. And then you multiply each number by 2, you get 10, 24, 26. You'll see that one quite often too. And then we have 15, 36, 39, by taking 5, 12, 13 and multiplying each number by 3. We have 8, 15, 17, and 7, 24, 25. Once again, just know them. 7, 24, 25 is also another common one that is used throughout math. So you might as well just know it, learn it, memorize it, and then, hey, it becomes second nature. So in the bottom right here, it says the most common Pythagorean triples are in bold. So I kind of pretty much told you already. The other triples are the result of multiplying each integer in boldface by the same factor. Now let's take a look at theorem 9.2. The converse of the Pythagorean theorem. So right now, what I don't know is whether or not our triangle is a right triangle. Well, how could I figure it out? If I take a squared plus b squared and it equals c squared, then I have myself a right triangle. Okay, so by using the Pythagorean theorem, that'll tell me whether we have a right triangle or not. Now, we go to theorem 9.3, the Pythagorean theorem, inequalities theorem. This right here tells us, well, if I have three sets of numbers, remember, the biggest number is always going to be the hypotenuse, which is side C. So what they're saying right here is this: if I take c squared and it happens to be less than a squared plus b squared, then my triangle right here is acute. Okay, so that's what this first one is saying, the first part of that theorem. The second part of the theorem right here states that if I take c squared and it happens to be greater than a squared plus b squared, then this triangle happens to be obtuse. Okay, so think about it this way once again. We know obtuse is big, so if c squared, or side c squared, is bigger than the other two sides combined, then right here we have an obtuse triangle. And then we also shows when we have an acute triangle, once again, when c squared is less than a squared plus b squared. So therefore, that's why I remember I said, hey, oftentimes you'll see that a squared plus b squared is equal to c squared. Typically, we start with a and b first. But in order for us to figure out the whether we have an acute or an obtuse triangle, you may want to switch the equation where c squared comes first. And then you have yourself less than a squared plus b squared, or greater than a squared plus b squared, to determine whether it is acute or obtuse. All right, so let's take a look and see what we have here. On number one, it says find the value of x and tell whether the side lengths form a Pythagorean triple. All right, so it doesn't matter pretty much what side is A, what side is B. Okay, it's going to be the two legs. What does matter is where is C, and C once again is always opposite of the hypotenuse. So let's go ahead and put all this together right here, and I'll start off with 81 squared plus 108 squared is equal to c squared. Okay, a squared plus b squared is equal to c squared. So I'll put this all together right here, and we've got 81 squared. Looks like that is 6,561. 108 squared is 1,166, or actually 11,664, and that's equal to c squared. We're going to add things up. I've got 18,225 is equal to c squared. And then remember, the last step right here is to get rid of c squared. We got to square root both sides. And when I square root both sides, side c, or x, happens to end up equaling 135. So now the question here, or the last question, is 81, 108, and 135, is that a Pythagorean triple? Okay, so the question once again, if I take 81, 108, and 135, is that a Pythagorean triple? And in order to figure it out, start with like a 3, 4, 5 right triangle. can I divide each of these numbers? Can I take 81 and divide it by 3? Okay. Can I take 108 and divide it by 4? And take 135 and divide it by 5? And when I do that, is it the same and being the same answer or same number that we ended up with when we divide it? And actually, in this case, it is. Okay. You're saying how? Well, what if I take 3, 4, 5, right? We'll start with our basic Pythagorean triple. And if I multiply each of these numbers right here by 27, I'll end up with 81, 108, and 135. And that right there is the beauty of your Pythagorean triple. So this one right here, we know what the answer is, and yes, sides are a Pythagorean triple. All right, and then just like that. Let's take a look up next at number 2. So on this one right here, we have, I'll go ahead and say that 4 is A, X is B, 8 is C. And once again, it doesn't matter which legs you decide to say is A and B, but C must always be the longest side and be opposite of the right angle. So when we put all this together, I've got 4 squared plus x squared is equal to 8 squared. Let's simplify this out. I've got now 16 plus x squared is equal to 64. I'll subtract 16 to both sides, and x squared is 48. And then we want to square root both sides right here. And when I square root both sides, we got ourselves rad 48. But we want to try to simplify things in simplest radical form, and this ends up becoming 4 rad 3. So that right there ends up being x. So now the question is, the last part is do the side lengths form a Pythagorean triple? Well, 4 rad 3, let's try this again. The shortest side would be 4, and then we have 4 rad 3, and then 8. I don't know how I can start off with 3, 4, 5, 5, 12, 13, 8, 15, 7, 17, and 7, 24, 25. There's no way I could multiply any of those numbers and get 4 rad 3, and 8 by multiplying each at the same time. So therefore right here, Pythagorean triple, no, they don't form that, not on this one. All right, so that right there is kind of how we do things. You know, we figure out, use Pythagorean triple, and start with 3, 4, 5. See if you could multiply those numbers by 3, 4, 5, 6, etc. To get the 3 numbers that we currently have that you get as the answer. If 3, 4, 5 doesn't work, then you repeat it with 5, 12, 13, and then 8, 15, 17, and so on. All right. Let's see right here. I think we can go ahead and move on. Let's go next to number 7. It says right here, from school you biked 1.2 miles due south and then 5.5 miles due east to your house. And if you had a biked home on the street that runs diagonally from your school to your house, how many fewer miles would you have biked? So we got ourselves a good word problem right here. I always like to draw a diagram whenever we have word problems. So it says from school, and I'll go ahead and put a point right there, and I'll mark it as S. For school, it says you go down south. So that only makes sense for us to go down, and right here, this ends up being 1.2 miles. And then it says you go east, 0.5 miles. Well, going east, for me, it just means going to the left, right? as long as we know that going up happens to be north. Okay, so then we go east 0.5 miles. All right, and it says if you biked home on the streets and you go diagonally, so what that means is, hey, we go from here to here, that's diagonal, right? I put that in red. The question is, well, how many miles fewer would you have biked? Well, first off, we have to figure out, well, what's the distance from for that x? And guess what type of a triangle we have right here? No way, it's a right triangle. So we can use that Pythagorean theorem here to help us find the hypotenuse, which happens to be that diagonal. So I want to go ahead. We'll put our equation together. We got a squared plus b squared is equal to c squared, which happens to be x right here. So I went ahead and plugged in the substituted the numbers. All right. So now let's go ahead and put everything together. I take 1.2, I square that. I've got 1.44. Okay, 0.5 squared. We got ourselves 0.25. And that's equal to x squared. So now let's go ahead and simplify all of this. We got ourselves 1.69 is equal to x squared. And then don't forget, in order for us to get rid of that exponent, we square root both sides. And x is now equal to somewhere approximately 1.3. Okay. I believe this section, they want you to round. The answers have been rounded to the nearest tenth. Okay. So for this right here, rounding to the nearest tenth is key. All right. So from there to there, from diagonal of that street, that ends up equaling approximately 1.3 miles. All right. So it's a little bit shorter. Remember, the distance between 2 points is a straight line, right? The shortest distance. So what happens if we go the long way where we go south and east, right? Well, if I take 1.2 and plus 0.5, that equals 1.7. Right, that's going the long route. So how many fewer miles do we bike? Let's take 1.7 and let's subtract 1.3 and we get ourselves 0.4. So our answer is how many miles less? 0.4 miles less. And that right there will be our answer. All right, let's go ahead next up to number 8. So on these problems right here, we're trying to figure out with these 3 points or 3 numbers, which are lengths of the triangle. Can we figure out whether we have an obtuse, acute, or an acute, obtuse, or a right triangle? And so remember, what matters the most is side C, okay? Because side C is always the longest side. Right here, let me go ahead and label. I'll put 90 for A, 216 for B, and 234 for C. C is always, once again, the longest side. So remember we had our equation in our theorem. It was like C squared blank. That's the question mark. It's either going to be greater than, equal to, or less than. And we can go ahead and put A squared plus B squared. Okay, and so we've got the $1 million question to fill in that blank. So let's take our numbers. I'll start with 234 squared. I've got now 90 squared plus 216 squared. Okay, so let's put all that together. Plug things into your trusty calculator. Make sure you practice that, because even simple things like this, when not practiced, when it comes time on the test or quizzes, I see students, they do all of this stuff correct and this part wrong, and then it becomes just a heartbreaking shame, and then they get the problem incorrect. 216 squared, we got 46,656. All right, so that's what we have. When I go ahead and plug all those three numbers into the calculator, and let's figure it out right here. Well, they end up looking like they're the exact same thing, right? When you take 81 or 8,100 plus 46,656, you end up with 54,756. And right here, equal, right? Since a squared plus b squared is equal to c squared, that tells me we've got ourselves a right triangle. The reason being, they're equal. Okay? Next thing, let's take a look next up at number 9. Now, you got to be careful. Don't fall into the trap thinking, oh, look at the three numbers. They're already in order of a squared plus b, or a, b, and c. Okay? They might not be, and that's how students miss these problems. But in this instance, a is 1, b is 1, rad 3 happens to be the longest side. Okay? Because think about this, rad 4 ends up being 2, and square root of 1 is 1. So it's got to be bigger than 1, right? Let's go ahead right here. We'll take rad 3, we'll square that. We got to figure out what it is, whether it's greater than, equal to, or less than. It's got 1 squared plus 1 squared. Rad 3 squared. Remember, when you multiply, or when you take a radical and you square it, it ends up being whatever it is inside the radical. So, because think about this, rad 3 times rad 3 is rad 9. The square root of 9 is 3. That same number right there. So 3. And then we got ourselves 1 squared plus 1 squared. So we got 1 plus 1. Last I checked, 3 right here is greater than 2. So if 3 is greater than 2, or the side c is greater than a plus b squared, a squared plus b squared, we have ourselves right here an obtuse triangle. All right, we figured out how to use that Pythagorean theorem to help us solve whether we have a right, obtuse, or acute triangle, and we can also figure out how to find one of the missing side lengths as long as they give us 2 of them using that Pythagorean theorem. All right, that concludes 9.1.